Alright, now welcome to the last video for this week on completing the square. Now completing the square is the name that we give the process where we convert a quadratic from this form into this form. Alright, now by now you should know that this form tells us the location of the turning point. Okay, so this form tells us the location of the y-intercept, but we need to know where the turning point is to be able to sketch it accurately. So I'm going to show you a process by which we can go from here across to here. All right, so it's called completing the square, and there are actually quite a few steps involved. So bear with me, and it's a kind of process that you can follow along with yourself, and you can just remember the steps and do it. All right, so here is a quadratic. We might have y equals x squared plus 6x plus 15 on the end. So you might be wondering why we do this. Remember, it's just to find turning point, the turning point of a quadratic. Okay, we already know the y-intercept. So we're going to take this middle coefficient, or the coefficient of x, we're going to halve it, make 3. Then we're going to square it to make 9. Then I'm going to add it in here. And because I'm not allowed to change the overall equation, I can't just go adding 9s into random points in the equation. After the 15, I'm going to subtract it out as well. So the net change here is plus 9 minus 9. Overall is 0. But now the equation looks different. And because it looks different, I can do something with it. All right. So this is what the equation now looks like. All right, but you might notice, if you're sharp-eyed, that the first 3 terms now are a trinomial, which I can factorize. So you might notice that there are factors of 9 that add to make 6. They are 3 and 3. So I'm going to write my two sets of brackets like so. And I'm going to simplify what's happened afterwards, which is the plus 15 minus 9, which gives me plus, what does that give me? Plus 6. All right, now you might, if you're sharp-eyed, you might notice that I can rewrite these 2 brackets as squared and plus 6 at the end. There's always a y equals at the front. And now I suddenly have got myself this turning point form. So this has been, I've followed the process for completing the square, and I've transformed this into turning point form. Now I can read the location of the turning point directly out of the equation. So this is, the turning point is at minus 3, positive 6. All right, which will help me sketch it. So now I know that the y-intercept is at positive 15 and the turning point is at minus 3, 6. So if I was to do a quick sketch, I would see that it would look like this. There would be a point here at, let's call this 15, and then there would be a point at minus 3, which is 3 across, and 6 up, which I'll say randomly is there. I know that the quadratic goes up like this. All right, and I can see from that it doesn't cross the x-axis at all, which means that if I'd tried to factorize it, I would have had very great difficulty because it's not possible. Remember, factorizing shows us the x-intercepts, and given that there are no x-intercepts, I wouldn't have been able to do it. All right, so finding the turning point actually helped me sketch this where factorizing wouldn't have. All right, we'll do one more example, and then I'll let you go and try this on your own. So again, we've been given a quadratic asked to find the turning point. So I take this middle coefficient, I halve it, which becomes minus 3 over 2. I square it, which becomes 9 over 4. Now don't be afraid by the fractions. This actually makes it, it's not as hard as you think. All right, so then I add the 9 over 4 back in here, and I subtract it out afterwards to make sure that there's a net gain of nothing. All right, so then I'm rewriting this on the next line down. Plus 9 over 4 minus 1 minus 9 over 4. And I notice that these 3 are able to be factorized. And in case you hadn't figured out this sneaky little trick now, so to let you in on the secret, you might notice that this half of the middle coefficient is actually the factor that sits inside the perfect square. All right, so you don't actually have to do much after you've halved the middle coefficient and squared it. This is the number. that sits inside your brackets. So once you've halved it, you just chuck it in there and put a squared at the end. Then you simplify these two, so minus 1 minus 9 over 4 is minus 13 over 4, and there is your turning point has suddenly appeared. So the turning point here is at 3 over 2 minus 13 over 4. Alright, hopefully by now you remember that you have to read the opposite of this, but you can just read this one directly out. Alright, so turning point 3 over 2 minus 13 over 4, combined with the information we could read from the original one of a y-intercept of minus 1, allows us to get a pretty good sketch. So to do a quick sketch, we've got our Cartesian plane here, x and y axis. I can sketch the y-intercept at minus 1. I can sketch the turning point at 1.5 and minus 13 over 4, which is roughly 3.25, which should be somewhere down here. I can see then that there are going to be two x-intercepts here. I'll show you in another lesson how to find those two x-intercepts, because you can see that if you tried to find factors of minus 1 that added to make minus 3, you'd be doing it for a very long time. So just find the turning point, the y-intercept, and draw your nice smooth curve up, going through the points you know. We'll work out how to find those in another lesson.